Welcome to everybody out there in webinar land. This is our quarterly DriveSavers webinar on what's happening in the data recovery lab and what's happening in the storage industry. I'm really excited about today's topic of emerging data storage technologies, John, because it's really the focus of our R&D team to be aware of what's coming next, and most importantly, to be capable of recovering it when it actually makes it into the data recovery lab when the first field failures occur. And there is a bunch of new technology hitting the data storage industry right now, and it is very exciting stuff to talk about. I'll bring a lot of new terminology to you today. Hopefully you'll be able to absorb some of that, and we'll watch as this stuff rolls out into the industry here in the next couple of years. So grab your coffee, turn your brain on high, and listen closely. As John said, we'll pull a question at the end from the content today and see if we can give you that hard drive. And we'll try and have you out the door in 30 minutes or less after the Q&A. So without further ado, let's get started with the webinar. So the data storage market today, let's look at it for a moment as a baseline of reference. Hard disk drives have been around since 1956. The technology has not really changed that drastically from a functionality standpoint, but lots of things have gotten us to today's thresholds of 4 terabytes on a disk. The issue, however, in the global industry, quite interestingly, is that projected growth right now is a little bit negative. In fact, in 2012, the storage industry was down 7% in production from the prior year, with about 580 million SSDs produced, which was lower than what was expected. But then we step over to what we've been talking about a lot recently, which is, of course, solid state technology, with a lot of growth going on in Ultrabooks, MacBooks, MacBook Airs, premium notebooks, in the enterprise, in the cloud. Their growth curve is quite a bit different. Last year, we saw 39 million SSDs produced. In 2013, the industry is estimating about 83 million will be produced, for about 113% growth year over year, which is amazing compared to what the disk drive side of the business is doing. And today we're going to focus quite a bit on some of the new technology coming out in the hybrid space, marrying together solid state and hard disk drive technology. The first device we saw from Seagate was over 3 years ago in this particular arena, and now all the disk drive manufacturers have an offering in this game. And just yesterday, we had some brand new announcements. So we got some very fresh material to deliver to you today. So let's talk about disk drives for a moment. I don't know if any of you have seen that particular drive right there, the new ultra slim 5mm drive from Western Digital. It's about the size of a credit card, a little bit thicker, of course, but interesting where the hard drive industry is going on trying to recapture some market that flash is taking. Let's dig a little deeper here. So now there are three manufacturers of hard disk drives, that is. Western Digital, the big fish in the sea right now, with about 45% of the market, depending on how you measure it. They bought Hitachi, and as soon as the Chinese government allows the integration to finally complete, that will happen. Of course, they also got a very popular brand, G-Tech, in that acquisition. But currently, Western Digital, the Hitachi brand is now HGST, a Western Digital company, is what they're referred to as. Seagate used to be the big fish, but they're slightly behind Western Digital, HGST combined right now. Of course, they bought Samsung's hard drive assets. They also got the brand LaCie in their purchase. And Toshiba, player number 3 with 10 to 13% of the market, depending on how you measure it. They picked up Fujitsu's business a couple years ago. And very interestingly, we're going to start seeing these 3.5-inch drives coming from Toshiba again as a function of all this kind of shakedown in the hard drive industry. So in the market, we're seeing disk drive pricing actually decreasing just slightly, cost per gigabyte right now. These prices are fairly representative of retail market and consumer pricing right now. The density and performance, however, are at a capacity, and that's the big issue with HDD. We've kind of reached a wall, both with capacity in current form factors and with performance of HDD-only technology. And that's really what's kind of driving the change in the industry here. There are new designs for tablets and ultrabooks like that WD Ultra Slim you just saw. So again, the hard drive industry is trying to capture back part of what it's losing on the SSD flash end. But the drive industry is coming up with some solutions to get over the hump and to the next big capacity bump to get us to the 6 terabyte and higher capacities. And some of these new techniques have been talked about for years, but we're going to start seeing them shortly, and they very much are changing the way disk drive technology works. The first is shingled recording. If you're familiar with the technology, you know Seagate is pioneering it. The concept basically is overlapping data tracks. Therefore, they could get greater density in the same physical space. It creates some interesting issues, however, that are kind of NAND flash-like in requirement of erasing before writing the data. So it doesn't act like a traditional disk drive per se in how it writes data, but they get greater density on the disk by overlapping the tracks, just like the shingles on your roof. And we should see these devices soon, including possibly this year. The next one that you hear a lot of talk about these days, and there's always a couple of jokes related to helium, would be the helium-filled technology from Hitachi, now Western Digital. The idea with putting helium into a hard drive is a game changer. Hard drives will now be actually sealed completely hermetically. They will not have an atmospheric or a breather filter on them any longer because the helium will be trapped inside the drive. The reason they're putting helium in the drive is simply it has a much lesser atomic weight than oxygen, and therefore it has the ability to reduce turbulence on the spindle, increasing the number of platters and thinner platters that they can get into a drive. So the whole idea is basically greater density, once again, in the same physical 3.5-inch space. And we should see these devices probably next year, depending on who you talk to in the industry. And the big one, the holy grail that's been talked about for a long time, would be thermally assisted or heat-assisted magnetic recording, which is combining a laser technology to basically heat a bit as it is magnetically set. That allows for greater density, more bits per inch, and allows for a much more rigid write process. The difference here is they're going to have to retool a lot of technology to get to the thermally assisted recording, but it should bring great capacity beeps when we get there. So what about the recovery of hard disk drives? Well, this is what DriveSavers built its business on for the last 25 plus years. With existing drive technology, we have lots of experience with plenty of volume every single day in the laboratory. We continue to increase recovery rates internally in the laboratories, and continued development of tools for current technology are always in the R&D group. We might see a particular drive numerous times with a different type of failure each time, and we've got to be prepared for each one of those because there could be millions of them in the field. But what about these new technologies I just described to you? They are different, and we're all over it. We're thinking very much towards the future here, but we do need to test and define what new challenges we'll have with these disk drive technologies, and our OEM alliances with the drive manufacturers are critical to mastering these technologies, and R&D continued development, of course, for next generation tools that we'll have to build that don't exist anywhere else. But let's jump over to solid state right now. The particular technology that's eating up part of the hard drive space. Of course, there's a LSI SandForce controlled SSD. It's just a circuit board with a bunch of chips on it. We'll talk a little bit more about who the players are in this space. And now there are more than 100 plus manufacturers, assemblers of solid state drive. This list is not exhaustive, and there are probably more, and maybe a couple have already dropped off the list. But this is what the hard drive industry looked like 25 years ago. And now this is the SSD industry. It's a big pond full of a lot of fish, and there are some bigger ones in there, and we'll probably see this consolidate as the industry matures and grows forward. So let's look at the market. Costs are decreasing for NAND prices are always a little volatile, but in the last year, we saw retail pricing drop dramatically, down to a terabyte of consumer-grade SSD at $600, which is amazing compared to what it used to be. We see density and performance increasing. They have not hit the same wall that the disk drive industry has hit by any means with new types of NAND and new controller technologies. New interfaces. SATA isn't new, it's been around for a long time. mSATA and proprietary versions of mSATA to PCI. PCIe, of course, PCI Express, that is on the motherboard, and embedded flash solutions, whether it be in a phone or a tablet or some type of ultrabook. And new storage OEMs. As the big companies are hurting today in the storage space, some of the new companies starting out taking advantage of these new technologies are actually doing a great job. You can't ignore companies like Nimble or Skyera, Virident, FastStore is another new up-and-coming technology using networking technology over flash. So lots of new companies coming up into the storage space. Very interesting stuff there. The component suppliers. This is a great little synopsis of the industry right here. Here's basically who's making the flash, and this shouldn't be a huge surprise. Samsung, Toshiba, and SanDisk together, Micron or the Intel Micron Initiative, and Hynix out of South Korea, driving the vast majority of all the NAND on the planet right now. And the controller manufacturers, although this is not an exhaustive list, it's a list of some of the most popular controllers you'll find on SSDs in the marketplace today, from SandForce LSI, of course LSI bought SandForce, Marvell, who has dominated the disk drive industry for controllers for a long time, IndyLinks, owned by OCZ, J-Micron, Samsung, Toshiba, and of course Intel, with their latest announcement of the new SSDs for the data center, are doing their third generation Intel controllers on those devices. But these companies make up that 100+ list, basically, of all those SSD assemblers. The LSI SandForce controller technology, which is, 3 years old, really did change this entire game of solid state. DriveSavers is very proud of the fact that we are the only SandForce trusted data recovery company and understand their technology as best we can for data recovery in the lab, and look at all the companies who are currently using their controllers on SSDs. They are dominating the space right now, but we'll see how the controller manufacturers kind of flesh out here in the future. So what about new SSD technologies? Well, we have now seen our first consumer-grade SSD using triple-bit, 3-bit TLC NAND flash. The Samsung 840, some of you may own this device. It's very popular and it's selling a lot right now. It comes in two flavors, the Pro and the consumer version. And the difference is that the consumer version is now using TLC NAND flash, and the Pro version is actually using the MLC flash. So what has this done in the industry? Well, you can look at the chart to see the old SLC, highest grade, most expensive initial NAND flash we were using for enterprise, has program erase cycle limits at 100,000 per cell. When we switch to MLC, or multi-bit, which is actually 2-bit technology, which is what the vast majority of the solid-state drives today are, we go all the way down to 3,000 program erase cycles per cell, which sounds like a very low number, but is mitigated quite well by the controller and over-provisioning of the flash. We actually have the eMLC category now, which is Enterprise MLC, which fits between SLC and MLC, but onto TLC, which you find in a lot of consumer USB stick devices, now shipping in SSDs with a program erase cycle which is quite low, but again, mitigated via the controller so that the device lasts as long as it needs to, but it's also much slower to write or to program, as you can see. So as the as the solid-state drive industry is trying to really tackle pricing, they are going to 3-bit technology now to drive pricing down, capacity up, and adoption up of the SSDs. But on the other side of performance, we're looking at solid-state drives on PCIe interface, which is actually becoming probably the most popular growth point with solid-state. Here pictured are a couple different devices, LSI in the enterprise, and the new MacBook Air SSD. Apple, the first company to put PCIe storage in a consumer device, will likely change the way other notebook makers are deploying these, because the performance is incredible that they're getting out of a solid-state drive in a $1,000 notebook. So let's talk about PCIe for a moment. It's the interface of choice in enterprise, whether it be Fusion IO's IO drive, EMC's newly branded Extreme SF, LSI's Nitro Warp, OCZ's Revo, Virident's FlashMax. They've got great names, that's for sure, and they're incredible performance devices putting what used to be a whole server cabinet full of disk drive speed and technology now multiplied by a factor of, or an exponential factor, and put onto a single card in your computer. And then Apple, that new MacBook Air with, again, the proprietary interface, offers PCIe in a consumer-grade device, and they're actually sourcing, it looks like, two different vendors, both Samsung building one and Toshiba SanDisk building one for them, which are probably going to be Apple proprietary. We have the new MacBook Air in the lab right now, and we're already able to provide imaging and recovery from them logically. The next step is going to be to develop a special adapter so that we can read these SSDs individually. Very exciting stuff coming from Apple in that space right now with incredible 800 megabyte a second read-write speeds. So fun stuff happening in the enterprise and in the consumer. So what about the recovery of solid-state drives? Well, device failure, as we've talked about before, is really binary. It's either working great or it's totally dead, and the issues are either the NAND flash failing or something in the controller or firmware having a problem. There really aren't a lot of swappable components in today's encrypting drives, so we have to work with those components to resolve them. Physical and environmental issues, of course, are always true. Impact or physical trauma to a device or liquid or environmental exposure will bring your SSD down just like your hard drive. User fault, of course, SSDs don't prevent users from making mistakes. Of course, they just enable users to make the mistakes much more quickly, unfortunately. And self-maintenance routines. These aren't technically causing data loss, not at least from our perspective, but they are maintenance that are causing deleted data or old or stale data to be erased and eliminated from the SD. But there's a lot of talk about what you can and can't do in the recovery of data that has either been trimmed or garbage collected. But on to what's the really fun and exciting stuff to talk about right now. And Seagate said the industry would go this way some years ago. And what we're talking about are hybrid drives. There's a picture of a Seagate Momentus right there for you. And of course, a new acronym, hint, hint, a new acronym being added to the arena of SSHD, solid state hard drive or solid state hybrid drive, depending on whose definition. It's HDD and SSD combined in one ecosystem, really. You get the best of both worlds, performance and price. So how are companies rolling this out? Well, each company, of course, has its own flavor, its own version, and its own technology on how they're coming to market with solid state in a hard drive. So Seagate was first to market. I think we're in generation 3 right now of their Momentus devices, and the current generation is a great device. They're using 8 gigabytes of MLC flash and treating part of it as SLC flash, actually, combined with a 500 gigabyte or 1 terabyte platter drive, all in the same little 2.5-inch enclosure. It's a great looking device. The goal is to make it feel like an SSD for most operations, but give you the capacity and the price of HDD. It is truly plug and play because everything's managed in hardware via this controller on the device itself. It looks like a hard drive, acts like a hard drive, but provides performance like an SSD. Western Digital's got its own technology. Of course, they have to do it differently, but depending on the configuration, you can get 8 to 24 gigs of an embedded SSD from SanDisk attached to or inside of the Western Digital hard drive. So it's really two different devices, but inside the same enclosure, and it's a software managed solution with driver support for Windows only currently, which seems a little interesting to take away the performance in hard drive controller and give it back to a software driver, but this is where Western Digital is putting the technology right now. And just to make sure it's plenty complicated, Toshiba has its own design as well. Toshiba, being a huge player in the NAND flash industry, has got an advantage there, and they're doing an 8 gigabyte MLC NAND flash plus DRAM in both a 7mm and a 9mm drive. So we can see that all the hard drive manufacturers have now offered up their own flavor of hybrid drive technology. So what about in the enterprise? Brand new news, just available as of yesterday, announced maybe last week. We have the first enterprise grade hybrid drive. IBM is offering up its SAS, which is serial interface, a nice expensive enterprise device for their System X, built by Seagate. And this is the first time we've seen 10,000 RPM in a hybrid drive. This is really an exciting device in this space and will end up in a lot of servers, I'm sure. They're doing a 600 gig capacity. Again, it's SAS. It's not made for high capacity. It's made for high performance disk drive. But look at the throughput, 151 megabytes a second, which is very fast for a hard drive, is quite slow compared to pure SSD. So here's the way the industry is going. The latest, greatest, fastest enterprise hybrid drive is significantly slower than a consumer-grade SSD hitting the market right now from Apple. But it's a different application. So interesting news right there. And I just want to define something for you to make sure it's clear of hybrid drives versus what we would call SSD caching or tiering of storage. Apple's Fusion drive is not truly a hybrid drive. It's two separate devices. It's 128 gig SSD and an individual a 1 or 2 terabyte hard drive. These two devices are managed via a logical software layer, part of Apple's core storage code, that allows these two devices to look like one single LBA device. So that's Apple's particular technology. Intel has its own, which is the Intel SRT, which is smart response technology. It allows SATA SSDs to function as cache devices for hard drives on Sandy Bridge and later motherboards. And of course, in the enterprise, we've got the technology which has actually been around for a little while, enterprise level applications from EMC, FAST, which is their technology, fully automated storage tiering, their different cards in PCI and their Extreme IO racks of SSDs integrated into this technology. Very, very fast stuff. High-level enterprise devices, very cool stuff. So that's the difference of SSD caching or tiering versus hybrid technology. So what about recovery of these devices? Well, it's evolutionary, not revolutionary, as far as the technology goes from our perspective. Expectations are comparable for recovery rates to traditional hard drives, and that has already been shown in the lab with some of the devices we've already been recovering for the last couple of years from Seagate. The Seagate SSHD, as I said, we've got great recoverability on the prior two generations and working on current ones now in the laboratory. Western Digital's we don't have yet, as with Toshiba's latest device, we don't have yet, but we will soon be testing those. And the Apple Fusion drive has offered very high recoverability testing in the lab, but we do require both devices from the customer, of course. They come in, you can put it in a mini or in a desktop iMac, but we do have to get both devices from the customer, and it does offer, unfortunately, a higher potential failure rate because two devices are acting as one. So there's a lot of information in a short amount of time. Try and digest it for a minute. In 20 minutes, we just cranked through everything that's happening in hard drives, solid state drives, and in hybrid technology. Some stuff you may have been familiar with, some stuff that's not yet even to market. I don't know if you got all of it, but try not to forget, because there will be a quiz in just a couple of minutes and test your knowledge retention. So now that we've taken a breath, let's look forward for a moment. What are we thinking about as we move forward? Well, greater market adoption of solid state technology, that's for sure. Everything mobile, corporate, and enterprise is going that way. And with great growth in the industry, we will continue to see more devices in the field. 25% of the storage market, depending on whose numbers, iSupply or IDC you look at, by 2016. Hard disk drives capacity is definitely going up. Prices will be coming down, and we'll see growth in the data center, primarily for those really high capacity drives. And new technologies will always equal new challenges for us. More security, more encryption, and more secret sauce on all of these devices as they come out, or the proprietary IP of the manufacturer. The sanitization of data from flash and SSD technologies is probably a future webinar topic, as is the forensic recovery of solid-state devices. As DriveSavers grows its forensic division as well, we'll probably cover those topics in a future webinar as well. But that concludes my content portion. I'm sorry I ran about 2 minutes late there for the webinar, but we'd like to open it up to question and answer, and John Christopher will manage that for us. I'll let him take over for just a moment, and when we're finished with that, we'll follow up with the raffle.
Awesome. Okay. All right.
John?
So here are the here is the here's the question to the question. We're wondering if all of you have access to a questions box in your GoToWebinar control panel. And there's one yes. Yep, yes. Okay, cool. So to answer questions, we are hoping that you will use the questions boxed. And there was one question that came up right near the beginning from Bob Hogan. I'm not sure if we answered this, but I think we did. Bob asked the question. He said, it seems that the hard drive is being replaced by the solid state drive. Do you think this is the case, or does the hard drive have a future? So I think what Bob really wants to know is, are good old Winchester technology type drives going to be replaced by hybrids or SSHD or some other type of device? What do you
Well,
think?
John, I'll field that one. So great question, Bob. Slowly, flash technology is replacing disk drive technology. Disk drives are not going to go away completely, not in the near future, that's for sure. Again, the projections are that 3 years from now, the entire storage industry will only be 25% solid state. So yeah, if you're working in the disk drive industry, I'm sure you've got some job security for some time, but it wouldn't be a bad idea to be looking over towards the solid state side of the business. One quick note on that is that we talk a lot about NAND flash in solid state. We're not so sure that NAND flash will be the type of solid state technology we're looking at in 10 years. It might be a different type of non-volatile memory, but disk drives aren't going away anytime soon.
Excellent. Thank you, Chris. Next question. We hear the question is, I heard that hybrids use the SSD to store more common used data. Is that true?
Not in all cases. Each different manufacturer has a different algorithm that they're using to manage the data between the solid state component and the hard disk component. And in fact, in Intel's technology, which I guess is, again, caching technology, they're doing it more like almost like a RAID 0 in a way, as is Apple with their Fusion drive. But inside of the actual hybrid drives, again, different algorithms from each manufacturer as to what is stored on the flash and what is stored on the disk. But primarily, they're trying to give you performance boosts from most recently needed and used items in the flash, and the stale or legacy or once written data goes over to the disk side.
All right. Next question. Any optical SSD drives in the future? Something that might use photons instead of electrons?
Wow, that's an excellent question. I am not currently familiar with any development of optical technology inside of these, although we have gone through a lot of different optical technology over the years. And in fact, phase change technology, which we saw in a lot of optical devices a few years ago, is now being deployed, of course, in memory. And some of the new non-volatile memories that I just alluded to a moment ago are actually what we're calling phase change, but not phase change in the same way of optical. So we'll be watching for it, but I'm not aware of any right now.
All right. This one might be a tricky one for you, Chris. Can you predict in dollars to gigabytes for SSD what we might be seeing in the next 3 years? Any guesses on something like that?
Excellent question. I bet you somebody like Tom Coughlin of Coughlin and Associates has a great answer for that because he does market research on this. I know that we are seeing a terabyte device right now on Newegg or Fry's sites for $600. That's pretty amazing on cost per gigabyte right there. That device was what, $2,000 a year and a half ago or so. So I don't have a good prediction on cost per gig moving forward, but it's going to be significantly closer than it is to HDD, but HDD will continue to reduce in cost as well. I will not offer a prediction at this point, thank you for asking. Let's look to the industry to give us some better numbers.
Okay. Here's another question. I'm seeing failures just as frequent with SSD as I have with spinning hard drives. Is SLC SSD a lot better? Is it worth using in consumer or small business?
Very, very good question. Your observation is quite accurate, I think, that you are seeing solid state drive failures at a similar but slightly lesser rate than those of traditional hard disk drives. I think a lot of people are under the misconception that solid state drives almost never fail, but those manufacturers who have put out annualized failure rates, I think Intel puts their numbers out there, show failure rates comparable to enterprise grade hard drives. So to your question, does SLC solve that problem? Well, SLC solves the problem of NAND flash itself typically wearing out to excessive program erase cycles. The other thing SLC gives you is, of course, better performance. But you're not going to see SLC in consumer devices because it's too costly to fabricate. What you're going to see and what you're really seeing and you should be looking for is eMLC, which is enterprise grade MLC in devices. And it's not always the NAND flash that is the source of failure that you might be experiencing. It could be firmware corruption or a controller related issue, not the flash itself. And I think that as the industry continues to mature, we will continue to see greater reliability. But I am not surprised by your observations, and no one should be.
Okay. SSDs seem to be slow when nearing capacity. Is that speed returned, or is the slower I/O speed permanent?
Another excellent question. So today's solid state drives, everything in the market right now, is utilizing BGC, which is background garbage collection, and trim technology. Those two technologies are supposed to work in the background, primarily garbage collection, to clean up the disk or the solid state drive flash as you continue to write to it. Writing at near capacity of a device should not technically slow it down depending on the historical usage of the device. That is straight out of the box or a device that's been written to and read from a number of times. There is over provisioning, of course, on the device, and there's extra flash on there that helps not really with capacity issues because you can't see that flash, but it helps with the wear leveling and the spreading out of the data across more NAND flash than the device actually reports to you. But a solid state drive in today's environment really shouldn't be slowing down that much in performance. But the best thing you can do is to run the particular software toolkit that comes from each manufacturer with their SSDs and run it against your device. And it is typically quite rich in the statistics and information it can give back to you, including the number of program erase cycles that you've already executed and the longevity of the device still left in it.
All right. With the hybrid drive emerging on the server side, are there any changes on how RAID is currently configured and recovered? For example, hot swappable drives in a RAID 5 configuration.
Another excellent question. John, I got to say these are the best questions we've ever had in a webinar. So the concept of RAID technology with solid state drives is new. Here's the deal. Traditional RAID technology, plain old RAID 5 algorithms or RAID 6 algorithms are not the best way to run SSDs in RAID. So all of the controller manufacturers right now are releasing or already have products that specifically cater to RAID on flash. One of the main reasons is that remember that no matter what SSD you're using, you want to limit or mitigate the number of writes you're doing to the device, right? And in traditional RAID technology, there is a ton of overhead in writing metadata, parity data, and all kinds of other information all the time on drives. So yes, RAID technology is changing for flash, and there are some startup companies right now who are specifically coming up with new RAID algorithms based on historical ones that exploit the advantages of flash and deal with the weaknesses of it as well. So really good question.